Alright, let's begin. So for this video, we're going to be showcasing the Skybox as well as the particle system. So as you can see, we have a inverted square to represent the Skybox. If I were to just showcase, we got the lower part of the Skybox down here, as well as the upper Skybox part. So if I were to just spin around, you can see that we are properly encased inside of the Skybox. We also have inside the center, we have our particle demo here. So here you can see the particles facing towards the camera as I spin around it. So to start off, we'll talk about the skyboxes. All scenes have a singular active skybox at any given time. You can set and get them similar to the terrain, and these are rendered during the draw step. If the user does not define a skybox, then we have a null skybox that does nothing during the render stage, which is managed by the skybox manager over here. For the Skybox Manager, for the assets, I have a little documentation here to showcase what the texture needs to look like for the Skybox, as well as highlighting that if the texture does not exist before the Skybox is defined, it will crash the code. So this is some documentation to showcase how you would want to create a Skybox. For loading the Skybox in, you pass in a map key. If that map key exists, we crash hard, crash fast. We pass in a length parameter. This determines the length, width, and height because skyboxes are perfect cubes. Pass in any Y offsets you want for the skybox, and then the map key associated with its texture. Passing in all of that allows us to create a skybox where we will just create a inverted cube with the proper inverted winding to showcase that. And then we create the skybox model using the vertice, triangle, list, and vertex and try, all of that. And then we create the graphic object, passing in the default shader texture key, as well as the texture key for the texture the user wants. With all that said and done, we delete the vertices and triangle list. We have a render stage, and then we have the deletion of the skybox. That is it for the skybox. Onto the particles. So for particle effects, I also have some documentation to showcase the process of creating a particle effect. It shows a bunch of the various parameters that can be adjustable, and also references the base effect class, which will go into further detail of what each of these individual steps entail. For loading them in, though, you just pass in a effect. It will check to see if the map key passed in exists already. If it does not exist, it will create a new effect and copy all the data from that given effect. So if I were to go to load resources, you can see we just create an effect with a bunch of parameters, load it in with the load call as a pass by through to have everything. For the effect, this will do some copying of the data, so whenever we do that new call, we will pass in the emitter life, set the graphic object, create the graphic object, and then create the new emitter. We have to set the graphic object separately because once a graphic object is created, we don't have access to all three of these parameters. So when the user loads resources in, they will determine what model, shader, and texture they want here. And then once the effect is actually created inside the asset manager, it will create the new graphic object. As for the parameters, the effect also serves as a pass-through for all the parameters necessary for the emitters, burst, and particles. So for instance, it will set the lifespan, the position, the burst life, the delay between bursts, the scale, the particle count, the direction and speed. All of that is passed through by the effect. All of them have an option for randomization. The main exception is particle speed and scale. These can be randomized. However, these are randomized on a burst basis rather than a particle basis, so all bursts will share the same speed and scale. So there's also a pass-through for the graphic object that is passed down. You can either play an effect permanently or temporarily. Temporarily will submit entry using the emitter lifespan. Playing it permanently will have the effect last so long as the scene is active. Moving on down to the emitter. So as I mentioned during the effect with the copy, this is where we can copy in all the data from the given emitter. So this copies in the burst delay, life count, direction, speed, etc. Position for the emitter is not something that can be randomized. It's one of the few things that is not random. When you submit entry without a lifespan, it will just last forever. It will just create a burst and then have a randomized delay for when the next burst should occur. If you pass it in with a lifespan, it will call a alarmable for alarm 0, and when that alarm is up, it will exit the emitter from the scene. Alarm 1 is where we loop all through with random delay to create more bursts. For the creation of a burst, we have a factory pattern associated with it. So all bursts have a factory pattern where we create a new burst if the pool is empty. Otherwise, we just grab from the current pool and remove it from the pool because it's being used now. We have some getters and returners. We have a clear here to delete all the bursts in the pool. This clear is called whenever the burst factory is deleted, and the burst factory will allow the emitter to get and return any bursts they are using. So bouncing back to the emitter, when we go and create a burst, we randomize the scale for that burst, we randomize the speed for that burst, and then we pass in the position, scale, the range of directions that the particles can have, the speed, and a random particle count. And then we insert that into the multi-map with a randomized lifespan using the time manager to determine when its time is up. When it's time to draw the particles, we will first loop through our multi-map of bursts and find out when we either reach the end or find a burst that is not expired. Every burst that is expired will have their particles cleared and be returned to the factory before being removed from the multi-map. Once we cleared out all the expired bursts, we then loop through the remaining bursts and have them draw their particles. Clearing the burst just involves once we are done with everything, so once we are submitting exit, there is a clear burst step. This clear burst step loops through our multi-map and clears all of the active bursts, returning them all to the factory so that they can be deleted by the emitter's burst factory. For bursts, when they are created, with a count, with the set count, that is when we set our vector size, and then we loop through our burst count, get particles from the factory. So the burst also has a factory of particles, which again, standard object pool and factory shenanigans here. On deletion, that is when we empty the object pool. So when we set the count, we loop through all those bursts, all those factory bursts, put them into the group, randomize their direction, provide them with their constant speed, and provide them with a 000 position. The position of the burst is stored separately, and that is used during the updating particle stage. So we compute the scale matrix with the scale, compute the translation matrix using the emitter position, and then direction is done with billboarding down here during the draw particle step. So this gets the graphic object as a pass-through all the way from the emitter. It will get the update the particle, get its new position and direction, calculate the rotate orient using the current camera's forward and doing the cross products. That will allow us to create our world using the scale, the rotate orient as the rotation, and then the translation being the position of the particle multiplied by the position of the burst. That will allow us to set the world for the graphic object and then render it to the scene. Whenever a burst is destroyed, we will return all of its particles to the factory and then delete the factory. For the particles, they are a simple strut. This strut is associated with a position, direction, and speed. Whenever the update is called for the particles, then it will compute its position using direction times speed plus position, standard linear movement. And then we have a getter for getting the position and direction. This is used by the burst to determine where its position is during the draw particle stage. And that's it.